To question 7 of SMOPS 2015. This is a slightly tricky question, so I'll give everyone about 5 minutes to do it. Okay, pause this video, try it right now. So I'm going to go through this question and I'm going to give you some tips at the end, right, as to how you can really better deal with these sorts of questions. First, we're going to notice, right, for any of you that tried listing out, right, instead of finding the last 4 digits, let's first find the last digit of n, okay? The last digit of n must be 5. There is no way that the last digit of n can be 1 or 2 or 3 or 4, because if you try that, you will not be able to end with 5, right? You will not be able to end with 2015. So that's a very powerful insight. But here's a separate question we can ask, okay? How can we algebraically represent 123, right? Algebraically representing, plausibly we could do something like 100 plus 20 plus 3. But let's take this a step further. We can do this as 1 times 100 plus 2 times 10 plus 3. So this seems a bit weird, right? Like, why would you need to do this? Obviously this is true, but why? Why do you need to do this? Because if the last 4 digits of 411n is 2015, then n is some number such that 411n is equals to this expression for some integer m. And so let's say m is 3412. Then 10,000 times m is equal to 3412 with 4 zeros at the end. When we add 2015, it slots in perfectly. It gets us the last 4 digits of 411n. So then we continue this analysis. Since the last digit of n is obviously 5, we will let n equals to 10k plus 5. Again, the same thing. K can be any number in the world. We times 10, which means we put 1 0 at the end, and then we slot in a 5 at the end. Okay? If we write n as 10k plus 5, we can substitute. This is a very powerful algebraic trick. Substitution. We will be able to simplify our expression to get 411k is equal to 10,000 m, 1,000 m minus 4. Then the last digit of k must be 6. We will continue this way until we find that, oh wow, the last 4 digits of n is 2365. 2365 is an answer. Obviously, 12365 is an answer. 22365 is an answer. But we want the smallest value of n, so we just write 2365. Let's extend this question, alright? But before I talk about that, let's go back. I want to remind everyone, okay, that in Maths Olympiad, some questions are going to be very, very tricky. And this is really one of the tricky questions that I don't think that everyone is expected to be able to do. It's okay to skip this question first and come back to this at the end, because this is a very tricky question. Right? Grab all the points that you can first before you come back here. There is no penalty for having your OAS being shaded up to question 6 and then you skip one question. It's okay to skip a question. Okay? It's better to grab more points than to waste too much time on a question that you may not have the right answer on. Okay? So question 7, let's extend this question, right? If you're familiar with this now, let's try to change this up. We have a number x, and we know that the sum of the last 2 digits of x is 11. The last 2 digits of x squared is 36. So what can these last 2 digits of x be? Alright, think about it. This is a very tricky one, but think about it. How can we solve this question?